Hello everyone, Namaskar, welcome to Maths Guidance and welcome to the second lecture of chapter number 9, that is areas of parallelograms and triangles. Okay, so in the first lecture we have studied that there are some figures lying between the same parallels and on the same base. Okay, we have seen it through so many examples. Now let's come to the second lecture, and in this lecture we are going to see two theorems having the theorem is like this, that the parallelograms on the same base and between the same parallels are having equal areas, first of all, and second one is related with the triangles, one triangle and one parallelogram between the same base and between the same parallels. Triangle is having the half area as that of the parallelogram. So we will understand both the theorems and we will solve some examples also, problems also. So let's start this lecture number 2. All right, let's start the video. Thank you very much. So the topic is parallelograms on the same base and between the same parallels. Okay, so let's start the topic. Let's understand it through one activity, then we will go to the actual theorem. Okay, let's start through the activity. We will understand it through the activity. So let's draw a parallelogram on a thick sheet of paper. Okay, on a thick sheet of paper like this. This is the parallelogram having vertex A, vertices A, B, C and D. Okay, now let's draw a line here like this, DE. Okay, DE is a line, so that triangle ADE, there is a formation of a triangle ADE. So on another sheet of paper you cut a triangle congruent to this triangle like this. Okay, you cut a triangle congruent to this triangle and you name it A dash, D dash and E dash. Okay, on a separate sheet of paper you cut a triangle congruent to this triangle like this. Okay, now you have cut a triangle congruent to this triangle. Now you place this triangle here. You place in such a way that this side A dash D dash coincide with BC. Okay, so the new figure let us draw here. The new figure will be, so this is the construction A, E, B, C and D, and we have to place this one here like this. Okay, so it will be like this, B dash, D dash, and here also A dash and D dash. So these will coincide. All right, now you see we have two parallelograms, one is ABCD and one is EE dash CD. We have two parallelograms ABCD and EE dash CD lying on the same base CD, lying on the same base CD and between the same parallels, and what are the same parallels? AE dash and CD, AE dash and CD. All right, so there are two parallelograms on the same base and between the same parallels, AE dash, C dash. Now what we can say, since these two triangles are congruent, triangle ADE is congruent to triangle A dash, D dash, E dash. So we have studied in the first lecture that these two will have equal areas. Area ADE will be equal to area A dash, D dash, E dash. We can say this. Now let's come to this figure. Area ABCD, we want to write area ABCD, that is equal to, we can write area ADE plus E A dash CD, E or EB, let's write it EBCD, okay, area EBCD. That is equal to, we can write in place of this area AD, we can write this one, area A dash D dash E dash plus area EBCD. Now you look here, area EBCD and A dash D dash E dash, that means what? That means E dash C dash, E dash C and D, that is equal to area E dash C and D. That means this parallelogram and this parallelogram are having equal areas, means ABCD and E dash CD. Two parallelograms are equal in area, that means two parallelograms are equal in area, okay, and these two parallelograms are lying on the same base and between the same parallels, okay. So from here we have got our theorem. The theorem is that parallelograms on the same base and between the same parallels are equal in area. So we will prove that theorem, okay. Let's move on to that theorem now. The activity is clear, I think. Now this is the theorem we have to study. The theorem goes like this: parallelograms on the same base and between the same parallels are equal in area, okay, which we have studied through the activity. Parallelograms on the same base and between the same parallels are equal in area. So we will prove this theorem. So solution or proof, okay. First of all, what is given? So let us draw the figure. This is one of the parallelograms, A, B, C, D, and this is another parallelogram, E, F, C and D. So both are on the same base, DC or CD, and between the same parallels, AF and CD. So given is two parallelograms, ABCD and EFCD on the same base CD, and between the same parallels, what are the parallels? AF and CD. This is given. Now what do we want to prove? We want to prove that these two parallelograms will have equal area. So area ABCD is equal to area EFCD. This is what we want to prove. Alright. So let's see the proof now. If you see here, you can see two triangles, this one and this one. So our first action is, we will prove these two triangles as congruent. Alright. Let's name the angles. Let us suppose this is angle 1, this is angle 2, this is angle 3, this is angle 4, this is angle 5, this is angle 6. Alright. Now we will use the concepts from the chapter lines and angles, because we know these are parallel lines. Because these are coming from the parallelograms. Okay. So now let's see in triangle ADE and triangle ADE and BCF. We can write angle 1 equal to angle 4. This one equal to this one. How? Since AD is parallel to BC, and AF is the transversal. So these two are corresponding angles. I hope you are remembering, corresponding angles are equal. Similarly, we can also write this angle 2 equal to angle 5. Alright, angle 2 equal to angle 5 we can also write, since this DE is parallel to CF. DE is parallel to CF and AF is the transversal. AF is the transversal. We can write it because this is also the sides of a parallelogram, DE and CF, parallelogram EFCD. Alright. Third one, we can write AD equal to BC. AD is equal to BC. We can write opposite sides of a parallelogram. They are equal. This is the properties of a parallelogram. Opposite sides are equal. Opposite sides of parallelogram ABCD. Okay. Now, since this angle 1 equal to angle 4, angle 2 equal to angle 5, so we can say that angle 3 equal to angle 6. Angle 3 equal to angle 6 from the angle sum property of a triangle. Angle sum property. Two angles are equal, then the third has to be equal. Therefore, by see this angle, this side and this angle, so ASA side is included. So by ASA rule, triangle ADE is congruent to triangles BCF. This implies area ADE is equal to area BCF. Since the two triangles are congruent, the areas are equal. We have seen it in lecture 1. Okay. Now, come to this figure. Area ABCD is equal to what? Now, area ABCD is equal to what? Is equal to area this triangle plus this figure EBCD. Okay. So, area ADE plus area area EBCD, and this one we can write this area BCF plus area EBCD. Now, if you see, area BCF plus area EBCD equal to what? Equal to area EFCD. We can write area EFCD. That means what? We have come to our conclusion. This is what we have to prove. Area ABCD equal to area EFCD. That is proved. So we can write that parallelograms ABCD and EFCD are equal in area. Okay. So we have proved this theorem very easily. Theorem is parallelograms on the same base and between the same parallels are equal in area. Let's move on. Okay, now let's come to this example. If a triangle and a parallelogram are on the same base and between the same parallels, then prove that the area of the triangle is equal to half the area of the parallelogram. Okay. So let's solve it. If a triangle and parallelogram are on the same base, okay. So let's draw the figure first. Let us suppose this is the same base AB. This is the triangle PAB, and we have to draw one parallelogram also. So let us draw the parallelogram AB like this. ABCD. ABCD is the parallelogram, PAB is the triangle. Okay. You can do like this also. Between the same parallels, AB and PC. Okay. Now we have been given one is triangle PAB and parallelogram ABCD on the same base AB and between the same parallels between the same parallels AB and PC. AB and PC. Okay. Now we want to prove area triangle PAB is equal to half of area parallelogram ABCD. ABCD. This is what we want to prove, because prove that the area of the triangle is equal to half the area of the parallelogram. This is what we want to prove. Now let's prove it. See the proof. First of all, we will do one construction like this. Okay. Q. Since this is P, we will write it Q. So we will draw BQ parallel to PA. Construction is draw BQ parallel to AP. Okay. BQ is parallel to AP. To get another parallelogram ABQP. To get another parallelogram ABQP. If you draw this, you will find there is a parallelogram ABQP. Okay. Now this parallelogram ABCD and ABQP lies on the same base AB and between the same parallels AB and PC. So we can write? Parallelograms ABCD and ABQP are on the same base AB, and between the same parallels AB and PC. Therefore, area ABCD is equal to area ABQP. We can say from the theorem we have studied that parallelograms on the same base between the same parallels are having equal areas. Okay. Now this triangle PAB and BQP. See, this is a parallelogram ABQP. It divides into two congruent triangles. We know this is the properties of a parallelogram. So triangle PAB and BQP. Triangle PAB is congruent to triangle BQP. PAB and BQP, yes, BQP. And since these are congruent, therefore area will be equal. Area PAB is equal to area BQP. And we can write this from the theorem that diagonal of a parallelogram bisects into two congruent triangles. Diagonal of a parallelogram bisect or divide. Diagonals of a parallelogram divide it into two congruent parallelograms. If you remember, this was the first theorem we have studied in our chapter number 8. Okay. Diagonals of a parallelogram divided into two congruent parallelograms. Sorry, into two congruent triangles. Alright. So from this theorem, these two are equal, so the areas will be equal. Now, this means area PAB. Now these two areas are equal. This area and this area are equal. That means what? That means this area is half of this parallelogram. Okay, ABQP. So area PAB equal to half of area ABQP. We can understand these two are equal and this whole is ABQP. So this will be half of this. And that is equal to half of area ABQP and CD. ABCD, we can write it because ABQP and ABCD are on the same base and between the same parallels. So we can write like this. From here, we have already established this one. That means we have got our result that area PAB is equal to half of area ABCD. This is proved. Very simple proof, but you will have to remember the properties or the theorems which we have studied in earlier chapters. See, this was an important important theorem. From this we established this one, from this one, all right. And this you have the one lecture before you have studied this one, that parallelograms on the same base and between the same parallels are equal in areas. So this theorem is proved. Okay, so let's now move on. So let's solve one question. In the given figure, P is a point in the interior of a parallelogram ABCD. This is the parallelogram. P is a point in the interior. Okay. So we have to show that area APB plus area PCD. Area APB plus area PCD is equal to half of area ABCD. All right. Second one is area APD plus PBC. APD plus PBC is equal to area APB plus area PCD. All right. We will solve it. Let's see the solution. So first of all, this is the figure and we want to draw a construction. We want to do a construction. It is like this: P, A, B, C, D and P. We will draw a line parallel to this one, parallel to AB and CD. This, let us suppose this is EF. All right. Now you see this ABEF. ABEF. This is E. This is E. This is F. ABEF. When you see, this is the base. AB is the common base of this parallelogram ABEF and this triangle ABP. So triangle PAB and parallelogram ABEF are on the same base AB and between the same parallels AB and EF. Okay, therefore area PAB is equal to half of area ABEF. We know from the theorem. Similarly, this PCD, area PCD is equal to half of area EFCD, because this is the common base and this is lying between the same parallels EF and CD. Okay, so this triangle and this parallelogram, this is 1, this is 2, using the theorem. Okay, now when we add these two equations, adding equations 1 and 2, what we get? We get area PAB plus area PCD is equal to half of area ABEF plus half of area EFCD, that is equal to half of, let us half is common, area ABEF plus area EFCD. Okay, so area ABEF and EFCD, area ABEF and EFCD is basically parallelogram ABCD, that is equal to half of area ABCD. This is what we have to prove. Area APB plus PCD equal to half of area ABCD. APB plus PCD equal to half of area ABCD. This is proved. So first one is proved. Second one, you can write similarly. When you draw a parallel like this, you will get this APD is equal to, let us suppose this is GH. APD equal to this one and BPC equal to this one, half of this one. So basically area this plus area this equal to half of this parallelogram ABCD. Similarly Similarly, we can write that area P APD plus area BPC is equal to half of area ABCD. This same way we can write this. Okay, therefore this is equal to this and this is equal to this. That means this is equal to this. Therefore area APD plus area PBC or BPC, that is equal to area PAB plus area PCD. This is proved. Okay. So one construction we will draw a line parallel to this one, and one construction we will draw a line parallel to this one, and similarly we can prove this thing. So using the theorem we have proved this, we have solved this question. All right. So friends, in this lecture we have seen two theorems. One was the parallelograms on the same base and between the same parallels are equal in area. In the second one we understood through one example that a triangle will have half the area of a parallelogram when they lie between the same base and on the same base and between the same parallels. So if a triangle is lying on the same base and a parallelogram is lying on the same base and both are lying on the between the same parallels, then the area of the triangle is equal to half the area of the parallelogram. All right, and we solved one question regarding this based on these theorems. So I hope this is clear. Now we will move on to third lecture. This chapter is very interesting. Please be connected with me, and thank you very much.